All right, friends, it's your boy, Mr. Shagney, coming at you with Unit 3, Lesson 6, Scaling and Area Homework. So today we explored what happens to the area when something is scaled when we know the scale factor. So we found out that when we know the scale factor of a number, right, we're going to take that number and we're going to square it, or we're going to multiply it by itself in order to find out how many times larger the new area is from the original figure. So that's really, this is the big takeaway here, is that sort of thing. So when we know the scale factor, we're basically going to square it or multiply it by itself to find out how much larger the new area is. So in question 1, it says, on the grid, draw a scaled copy of polygon Q using a scale factor of 2. Compare the perimeter and the area of the new polygon to those of Q. Well, first I want to find out the side length. So this is 1, 2, 3, 4, 5, 6. This is 2. 1, 2, 3, 4. This is side 4. This is the side of 1. 1, 2, 3. This is 2. This is 1. That is also 1. So we are going to multiply each side length by 2 to make polygon, to make the scale copy of polygon Q. So I'm going to first double 6. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this should be 12 units long. Then I'm going to double 2. 2 doubled is 4. 1, 2, 3, 4. I'm going to put 4 out there. 4 doubled is 8. 1, 2, 3, 4, 5, 6, 7, 8. Then I'm going to double 1, so that's 1, 2. I'm going to write these numbers here. That's 8. This is 2. I'm going to double 3, which is 6. 1, 2, 3, 4, 5, 6. I'm going to double 2, which is 1, 2, 3, 4. Double 1, 1, 2. And double 1 again, which is 2. So we're going to compare the perimeter. So to find the perimeter, remember, we're going to add all around. So we're going to do 6. So to find my perimeter, I'm going to take 6 plus 2 plus 4 plus 1 plus 3 plus 2 plus 1 plus 1. So 6 plus 2 is 8, plus 4 is 12, 13, 14, 15, 16, 17, 18, 19, 20. So we know the perimeter to be 20 units. Now when we talked about perimeter before, we know that perimeter is directly is affected by scale factor. And so basically what we're going to do to find out the new perimeter, so the way that we can find out the new perimeter of this shape is if it's scaled properly by 2, that means that we're going to take our perimeter and we're going to double it, right? So we're going to multiply that by 2, so we should get 20 times 2 equals 40 units. So our new perimeter should be 40, and we're going to check that work. So we have 12 plus 4, that makes 16. Then I have 16 and 8, that makes 24. Then I have plus 2, which is 26. Then I have 26 plus 6, which makes 32. Then another 4 is 36, 37, 38, 39, 40. So perfect. So the new perimeter of, let's say, scaled copy is 40 units. Scaled copy. Now we're going to talk about the area, right? So to find the area, these are weird shapes, and so one strategy we can use to find area is we can break them up into shapes that we know, right? So I can cut this into a rectangle here. I can cut that into a rectangle, so kind of 3 rectangles. That's one way to find the area, and then you just count how many there are here. So this is a 6 by 2, not a 6 by 2, a 4 by 2, which is 8. This is a 2. This is a 3 by 2, which is 6, 8, 9, 10, 11, 12, 13, 14, 15, 16. Area seems to be 16 units, and you can count the squares inside if you want to. So I'm going to break up the new area. And so what we're hoping for is we're hoping that this works so that if I take 16 and I times it by 4, it should give me my new area. But I want to make sure that that pans itself out here. So I'm going to break them into these rectangles here. So this is a 8 by 4, which should be 32. This is now a 2 by 1, 2, 3, 4. So this is 8. This is 6 by 4, which is 24. Okay, so 32. So we're going to see 32, 24, and 8. So we have 8, 9, 10, 14, 3, 4, 5, 6. So 64. So let's see if we take 16 times 4, that gives us 64. 6 times 4 is 24. 4 times 1 is 1, plus 2 is 6. So our area is 64. So the big idea here, friends, is that one, we scaled, right? We scaled this upward, we multiplied each side by 2. When we find the perimeter, right? When we find the perimeter of that, of the original, we're also going to multiply it by a scale factor of 2. When we want to compare the areas, to find the areas, we can break up the composite figures into basic rectangles or shapes that we can find the area of, or we can just count the squares inside. And then from there, what we're going to do is we're going to take the area, and we know that the area is multiplied by the square of the scale factor. So it's multiplied by the scale factor times itself, right? And that will give you the new area of the figure. So that is one big idea that we're learning in this unit. We're going to take this same information here and we're going to apply it to a new situation when you're given a table. So it says a right triangle has an area of 36 square units. If you draw scaled copies of this triangle using scale factors in the table, what will the areas of these new copies be? So we're going to take the square factor and we're going to square it. So that's 1 times 1 equals 1. That means that the area is 36. So now we're going to square this. This is 4. We're going to take 36 now and we're going to times it by 4. So 36 times 4. This is how we're going to find out the new area. So if this is our original area, we're going to times it by 4 if this is our scale factor. So this is 24, 12, 13, 14, 144. We're going to square 3. 3 times 3 is 9. Right? So now we're going to take 36 times 9. 9 times 6 is 54. 9 times 3 is 27. 28, 29, 30, 31, 32, 32. 324 is our new area. And I apologize, my 3 looks weird. Then we're going to take 5 and we're going to square 5. 5 times 5 is 25. We're going to multiply that by the original area. 36 times 25. 6 times 5 is 30. 5 times 3 is 15. 16, 17, 18. Add a placeholder. 6 times 2 is 12. 3 times 2 is 6 plus 1 is 7. 0, 10, 9. This is 900. Now we have a fraction. A fraction times a fraction. So what happens to this is the top is just going to be 1, and you're going to square the bottom number. So this is 1/4. So we're going to take a fourth of 36. So now we have 36 times 1 over 4. Put a 1 here. So this is 36 over 4. 36 divided by 4 is equal to 9. On this one here, we're going to square this. We're going to do 2 times 2, which is 4. And then 3 times 3, which is 9. So then we're going to take 36 times 4 over 9. I'm going to try to reduce. So I'm going to reduce here. 9, I can divide by 9 there and divide by 9 here. So this is 4. 4 times 4 is 16 over 1. This area is 16. So that's how I would solve this problem here, by just squaring each one of these numbers, which just means timesing it by itself. So I did 2/3 times 2/3 in case anyone's wondering. 1/2 times 1/2, 5 times 5, 3 times 3, 2 times 2, and 1 times 1. That is how I arrived at this number here, that I took that number and multiplied that number by 36 to get the number in the next number. So in here, I multiplied 36 by 4. Here, I multiplied 36 by 9 to get 324. Then I multiplied 36 by 25 to get 900. Then 36 by 1/4 to get 9. Then 36 by 4/9 to get 16. So I followed the pattern there. So that's that part. Next part of our homework says David C. drew a version of polygon P and labeled it Q. So this is a version of polygon P and it's Q. If the area of polygon P is 72, so we know the area of P is larger than the area of Q. What scale factor did David use to go from P to Q? Explain your reasoning. So this problem we're going to do as a warm-up in class, and it's going to help us understand what it is that we need to do in order to get this answer here. And so what we're going to start with is we're going to start by finding the area of Q. So how many squares do you see in Q? And so I see 1 square, 2 squares, 3 squares. I can probably make 4 squares. So that's 4. And then this could be counted as a half. So we know the area of Q equals 4.5. Now, what is the relationship between 4.5 and 72? Right? Like, how many times larger is that? So in order to figure that out, I'm going to take 72 and I'm going to divide it by 4.5. Now, when I have the decimal point here, I'm going to move this over there. At the end of every whole number is a decimal point, and I'm going to move that one over as well. So this problem becomes 720 divided by 45. I know 45 goes into 72 one time. I'm going to subtract. 12 minus 5 is 7. 6 minus 4 is 2. Bring down my 0. Now this should be, we're going to test our theory here. So I know that if I double 45, that makes 90. And I know 9 goes into 27. So 2, 4, 6 times maybe. So I'm going to try 6. 45 times 6. 6 times 5 is 30. 24, 25, 26, 27. So it is a perfect 16 times. Now, the area is 16 times larger. But that's if we're going from Q to P. This says that we're going from P to Q, so I need to know what the reciprocal of 16 is. So what is the reciprocal of 16? It's reciprocal, so reciprocal is 1/16, right? And so with this, now I have to ask myself, what fraction times itself will give me 1/16, and that will be my scale factor. So in order to find this, what I'm going to do is I'm going to take my fraction, I'm going to take the square root of 16. So I'm asking myself what times itself gives me 16, and that's really 1/4. And we're going to check our work here. 1/4 times 1/4 equals 1/16. So our scale factor in this problem, which took us a second, scale factor is 1/4. That's our answer. And in order to do that, we have to first find out how many times larger it is, then think about that in terms of that's if you're going from Q to P. So we're going from P to Q, so it would be the reciprocal of that. Then we have to take the square root of the denominator to find out our fraction, right? And that gives us our scale factor for that problem. So I apologize. So there's all my work so that you can see where we are in that problem. And then now we're going to look at problem number 4. So problem number 4 says, here's an unlabeled polygon along with its scaled copies, polygon A through D. So we know there's scaled copies. For each copy, determine the scale factor. This side, so I'm going to pick a side that's easy for me to count. This side is 2. This side is 1. If I'm going from 2 to 1, some of you might say that that's divided by 2. But instead of saying that, we're going to say times a half, because we know the corresponding side should be written as a ratio of 1/2. That's kind of how you know. This is also half of that shape, right? That's also how you could say you know. This side here, 1, 2, 3, 4. And this one, the scale factor is times 2. And I know I'm just sort of being a little lazy here. So that's times 2 because that is double of that, right? For here, this is 3. Now this one's a little complicated. So for this one, I'm going to write a ratio. I'm going to put 3, remember, copy over original. This is 3/2. That's your scale factor, and you're done, right? So I know that this is larger than that, and that so it's multiplied by 1/2. 1/2, 1 and 5/10 basically is what we're trying to say there. So this is equivalent to this. That's what I'm trying to say. So either one of those works. And then here, this is the same size. So this is a scaled copy of times 1. right? So that's how we get each one of those. The way that you can explain it is this is half of original 2 times the original one and a half times original, same as original. Those would be my explanations. Those would work out for this problem, and I'm good to go. The last problem says solve each equation mentally. So it says 1 times some number equals 1/7 times some number equals 1, right? So I know that a number times its reciprocal. So we're asking ourselves, what is the reciprocal of 1/7? The reciprocal of 1/7 is 7. So then I can check that work. 7 times 1/7 equals 7/7, which equates to 1. This one here, what number times 1/11 equals 1? Well, this one I know is 11, right? So 11 times 1/11 will give me that. So now I'm going to check my work. Then I'm going to say times 1/11. That equals 11/11, which equals 1. And then here, notice that in this problem, they're changing it up to see if you pay attention. So look, here we had 2 factors that multiply to give you 1. Here we have the 1 over here and a fraction. So we're missing the reciprocal of this fraction. So the reciprocal of that fraction would be 5, right? And so because 5 times 1/5 equals 1, right? And so they want you to start noticing that pattern that's happening here. So like, do you recognize a pattern in each of these examples? Like what's happening there? And so that's our homework for tomorrow. I hope you enjoyed the video.